Okay. Can everybody see that?
Yep, looks good.
Awesome. Okay, so tonight is going to be maybe a little bit on the technical side. I wanted to talk about Creel Survey because it's extremely important. So the state fishery, well, the tribal fisheries as well, you know, we both have our quotas. And Creel Survey is the tool that we use to monitor the state fishery. So through this tool, we estimate how many pounds of fish are coming out, how many pounds of fish are dying through hooking mortality and all. And so now, obviously, we can't, you know, count every individual angler coming off the lake. And so we have to estimate how many anglers are actually out there. And so what the Creel Survey does is it provides an estimate of angler use, and the I guess the number that we use is we call it pressure, and that pressure is measured in angler hours. And so what angler hours are is just if you're out there fishing for 1 hour, you just exerted 1 angler hour of pressure on the lake. If you and your buddy are sitting in a boat for 1 hour, then that's 2 angler hours. And so it's basically just the number of hours that anglers are spending on the lake. We also estimate fish harvest by number and weight. The way we don't weigh the fish as anglers are bringing them back, but what we do is every year we generate a relationship between the length of a fish and the weight of the fish, and that's based on our fall gill net survey. So in the fall gill net survey, we look at all the walleye that we caught, we look at how much they weighed, and we just basically it's just algebra. We generate an equation for how to convert the length of that fish to the weight. We also get a number of fish that were released, and that's based on how many fish anglers report to us that were released. And then based on that number of released fish, we also generate a hooking mortality by number and weight. And again, that's based on what anglers are telling us. And we talked about how hooking mortality is calculated last week. It's based on water temperature. We do that for both the open water and the ice fisheries, and we make estimates throughout the season. And so the way our fishing year runs is the year that our quota applies to actually starts on December 1st. And so the winter fishery, everything that happens in the winter fishery happens on the beginning of our fishing year. And so it happens, at the beginning, it starts to nibble away at our quota from the beginning. And the open water fishery happens at the end of our fishing year. And so that's why we have, sometimes we have to shut down our summer fishery either in August or frequently in September, because we've started coming up to our maximum number of fish that we're allowed to harvest, which is our quota. During the winter, we try to come up with 3 estimates that are through the winter. And so what we do is we look at that whole winter season and we try to divide it into 3 equal parts. And they're not always the same every year. The size of those parts are not the same every year because we never know when the ice is going to form, and also the end of the walleye season can vary by about a week. And but anyways, what we do is we try to divide that up into 3 equal chunks, and then we come up with an estimate throughout the winter. We come up with 3 estimates throughout the winter. The summer fishery is a little bit different. What we do is we have an estimate for May. And our May season can run anywhere from 2 to 3 weeks based on, and that's because of the way that opening day of walleye season is defined. And then after May, we come up with an estimate every 2 weeks. And so that's from the 1st of the month through the 15th, and then the 16th through either the 30th or the 31st, depending on how many days there are in the month. And so what we do is we just basically keep adding our 2-week estimates together, and we'll see how we're making progress towards our quota. Anybody have any questions on that? Cool. Okay, so the type of creel survey that we do here, and both the summer and the winter are done exactly the same way. They're called access-based surveys. And so what an access-based survey is, we have our the folks that are conducting the Creel survey, they're Creel clerks, are sitting at an access site, and they're counting people coming off the lake. They only count complete angling trips. And so if, in particular, this is something that happens in the summer in particular, is people will come off the lake, decide the fishing wasn't very good there, and they may go to a different access site. When the clerk determines that they're going to a different access site, so in other words, their fishing trip is not complete, those individuals don't get counted. The same kind of thing happens in the winter. You know, people might be coming off the lake for an hour to go grab some dinner someplace, or, you know, get a shower or whatever, because they're out there for multiple days. Those individuals are not counted as part of the returning, you know, the complete trip returning angler thing. During the summer, we also have issues with other users of the lake. So we know that there's water skiers out there, there's tubers, there's people just going over to a restaurant for the night. Those individuals are also not counted. So what the clerk's instructions are is to, I mean, first of all, if you're going to interview the people, it's obvious, you know, you just ask them if they were fishing. If they weren't fishing, they don't get counted. But for people that are coming back to private residences or resorts, maybe that they're not, that the clerk isn't stationed at, but are counting for those people, or are accounting for those people coming back from a day, what they do is they have to look for signs that that the people weren't fishing. So if there was a great big tube sitting on top of the boat or something, you know, a bunch of kids sitting in the boat, those people obviously weren't fishing, and they would not get counted as being a fishing boat. Any questions about that? Because that is something that people seem to get a little heartache over. Okay. So our Creel survey, this is Mille Lake during the summer. We have 33 sites that we survey, and those 33 sites are broken up into 8 clusters. And the reason that we break them up into clusters is because all of our counts are done on a 1-hour basis, and our clusters are visited in a random manner based on their expected use. And I'll explain how that works kind of towards the end of the talk tonight. And so what the reason we have to break them into clusters is because we don't want to have a clerk counting for 1 hour, say up in Garrison, and then randomly select at their next access site that they would have to work and be down in Isle. It wouldn't be very efficient because it takes like a half hour, 40 minutes to get there. So the clusters are set up based on the proximity of the access sites within those clusters. Okay, so let's talk about some of the findings that we've had in our Creel surveys. So the yellow bars here are angling pressure, and the red bars, or the yellow, well, all these bars are angling pressure. The yellow bars are winter pressure, and the red bars are summer pressure. And starting with the winter pressure, you know, there really hasn't been a tremendous change in the amount of pressure that the lake sees in the winter. If anything, it may have gone up in the last couple of years. But it's really important to note now that when we, the way we estimate pressure is based on the length of the fishing trip. And so now in recent years, with the explosion of ice castle type fish houses that are out there, and people going out on a Friday night and not coming off until Sunday morning, we can very well see trips that are 36 hours long. Now we know that they're not fishing for 36 straight hours, but there's really no way to tease out the non-fishing hours. And so our winter pressure that we're measuring in the recent years is a very different type of pressure than what we were measuring, say, back in 1990. You know, we know that there were some sleeper houses on the lake back in 1990, but it seems like a lot of our pressure back then was based on people that were maybe staying at a resort, going out for the day, and then going back to the resort at night. So it's a very different kind of pressure. So even though our most recent years of pressure seem like they're really high, and reality is Mille Lacs is a very high use lake even during the winter. It's a very different kind of pressure, you know, than it was in the summer. Now, what's important here, and this again, this is something I'm going to cover later, is that the amount of fish that we're estimating coming off of the lake is not based on pressure. It's based on complete fishing trips. And that'll probably make a little bit more sense to you the way I said that at the end of the talk. The red bars are our summer pressure. And what we can see is that summer pressure was kind of bouncing along at about, let's call it 1 million to 1.5 million angler hours. Some years it was up over 2 million angler hours. But then once our regulations started getting extremely conservative around 2012, 2013, we could see that summer pressure really took a big dive. And so, I mean, that has been a real change, you know, and the type of the way that we're measuring pressure in the summer is directly comparable to the way that we were measuring it back in 1990. So that's a real loss in the number of anglers that are coming up here, or the amount of time that's being spent up here in the summer fishing. So this then is the pounds of walleye that were harvested and released through our Creel survey. You can see that we've had 1 year, 1992, where we harvested over 1 million pounds of walleye in one summer. That was the highest that we've ever measured. But as time went on, so the tribes got fishing rights on the lake in 1997. And so starting in 1998, we started having to account for tribal harvest in our fishery. And so we started implementing some more conservative fishing rigs in 1998, 99. And what we see then is that up until 1999, the pounds of fish that were harvested actually exceeded the pounds of fish that were released. From 1999 on, we were actually releasing far more walleye in our fishery than what we were harvesting. But if you look at the magnitude of the fish that were being caught and then also released, you know, it's actually higher than it was up until about 1999. So 2002 was an extraordinarily high year of fishing. That was the year that the fish were extremely skinny, and I'm going to talk about that a little bit later in the talk. Other years that the fish were really skinny is like 2012, and then also in 2019, where we had really high numbers of fish that were caught and then being released. Does that make sense to everybody? Any questions about that? Okay. So last week we talked about hooking mortality. We've done some experiments out on the lake. And hooking mortality varies with water temperature. And it actually goes up much quicker than water temperature goes up. So it's not a linear relationship. So what we see is that when water temperatures or like about 60 degrees, so that's this bottom axis here. Okay, 60, you know, so colored right around here, 60 degrees, hooking mortality is less than 5%. Looks like it's about 2.5%, maybe 3%, somewhere in that range. But by the time water temperature gets up to 70 degrees, now hooking mortality is like about maybe 6 or 7%. And if it goes up to like 79 degrees, which I don't know if we've seen 79 degrees for any long period of time, hooking mortality would be like 20% of our walleye would die after being released. So that's really important. We like cold water. The red line on this is historical water temperatures. So that's like the daily average from 2001 through 2007. And what we see is that water temperatures are typically peaking kind of in this area here. So this is that in July, this is that July period. These are, I misspoke. This isn't a daily average. This is a 2-week average, which is how we monitor our water temperature for the Creel survey. So what we see is that the water temperatures peak early July, mid-July, depending on the year, into August. And by the second half of August, water temperature starts to drop. Just for comparison, I wanted to show you this 2021 temperature line. If you guys recall, in 2021, we had a very, very early spring and it got very warm in a heck of a hurry. And so in May, we had 60-degree water temperatures where or 61 probably, where our long-term average was probably about 55 or 53 degrees. And so you can see that when we're trying to estimate, or we're trying to come up with some kind of a reasonable estimate for what's going to happen in a particular year, the water temperature can have a huge impact for how we model what we expect harvest to be throughout the summer. And if you think way back to some of our earlier talks, one of the things that we do try to model is we try to model how much harvest there's going to be under certain regulations. And so water temperature is a huge variable that we have absolutely no control over, that can really raise heck with our estimates for what we expect harvest to be. So this is this black line here. Just kind of getting back to how water temperature changes through the year. These are our daily estimates. This is like over some period of time, and I can't recall what time period I used. But you can see that, again, our daily estimates, water temperature tends to peak sometime in July, first half of August, at which point it starts to drop. These bars here, this is how angling pressure changes through time. And again, this is like some kind of a long-term average. You see that we typically have our highest pressure in May. So from opening day of May, whenever that happens to be, until the last day of May, on average, we've got almost 400,000 angler hours of pressure during that period. It drops down quite a bit going into June, and then it keeps stepping down throughout the whole summer. And this is actually an extremely normal pattern for any kind of walleye fishery across the state. I imagine it's because, fishing tends to be really good in May. June, it still tends to be really good, but as the summer progresses, walleye fishing success tends to go down, and people just don't participate as much in the fishery at that point. They may switch to other species, maybe bass, maybe bluegills, crappies, whatever. But for whatever reason, they're not spending as much time fishing for walleye anymore throughout the year. And so what I've done here is I put this arrow here. So this is the time period for the last several years that we've shut the fishery down. We've had a planned closure, and that's because of a couple of things. We've got relatively high water temperatures, so it's probably right around the time that water temperatures are peaking, and we're still seeing relatively high pressure. And what isn't on this chart is angling success at this time of the year is also still relatively high. So as angling success declines throughout the summer, even though we've got maybe some higher water temperatures at this time of the year, what we've got is we're probably going to see less hooking mortality impacting our quota. And by shutting it down during that 2-week period in the first half of June, we potentially gain anywhere from 8 to 10 weeks of angling opportunity later on in the summer. Any questions about that? Cool. Okay, so now we're going to get into harvest and hooking mortality and how those things play out. So I hope you can see this, the dark on your monitors here, the dark green bars are open water harvest. So that's these lower bars. The light green bars are open water hooking mortality. And then these blue bars here represent the amount of harvest that we've got in the winter. If you recall, because hooking mortality is dependent on water temperature, and obviously winter water temperatures are much colder than they are in the summer, hooking mortality in the winter is essentially irrelevant. I don't even know if we get 1,000 pounds, maybe 1,500 pounds of hooking mortality throughout the whole winter, whereas we're looking at a lot of hooking or potential hooking mortality in the summer. So through time, we see that, with relatively, this is almost statewide regulations that we had back in 1990. We see that hooking mortality was relatively low because harvest was relatively high. Basically, at that time, if a fish came into the boat, it was probably harvested. And so we see that pattern consistently through here. And then as our regulations became more conservative, we see that a greater and greater portion of our harvest is being taken up by hooking mortality. And in recent years, the vast bulk of our harvest is taken up by hooking mortality. And so we've had some summer harvest like these last periods here, but summer harvest has been pretty limited. And so here in a few of these years, almost our entire quota is being taken up by hooking mortality. I wanted to cover yellow perch. They're kind of an interesting.
Larry
Oh,
had a
go ahead.
question on that last one.
Okay, go ahead, Larry.
Tom, as I understand it, then the hooking mortality that you're coming up with is based upon temperature and really doesn't have anything we do as anglers for using circle hooks, artificial bait really doesn't come into play, because no matter what we do and try how we release the fish or this, that's really not going to be taken into consideration. You're going to continue to go by the water temperature.
Right. So the reason that we do that, Larry, is when we came up with these hooking mortality estimates, prior to conducting those experiments, what we did is we had asked anglers how they were fishing. And so if they were fishing with jigs, Lindy rigs, if they were hauling crankbaits, the types of things that we would expect would possibly impact hooking mortality, we had some idea of that. And so when we did the hooking mortality experiments, we tried to get anglers, the anglers that were catching the fish, we tried to get them to proportion out their fishing techniques in the ways that we saw that anglers on Mille Lacs were already doing it. So if 25% of our guys were, or if based on the Creel Survey, let's say 25% of the people were pulling crankbaits, what we did is during our experiment, we tried to get 25% of our experimental anglers to also be pulling crankbaits. And the same if, let's say 50% of them were using Lindy rigs, then we tried to get 50% of our experimental anglers to be using Lindy rigs. So we tried to account for all of those variables.
One of the things that I hear the most complaints about is that people doubt that the accuracy of this hooking mortality that is often too high in these warm weather months when we should be seeing a lot of, have the greatest amount of hooking mortality. We should be seeing considerably more fish floating if those numbers were accurate. And I think that's part of where you and the DNR takes the most criticism, is that these numbers are not accurate, and yet they play such a vital part in our harvest that we can actually harvest. And so I guess what I'd kind of like to see is an additional hooking mortality study, or some way. What do you have for thoughts of getting this information out to the public that what you're doing is actually accurate, when the majority of the people that have fished this lake don't believe those numbers, Tom?
Yeah, I understand that, and I have heard exactly the same, complaints. There were actually two different hooking mortalities studies done. And the first one was done, I believe it was 2007, somewhere in that era. And at that time, there was some evidence that the size of the fish had an impact on hooking mortality. But there was a couple of issues with that, and we didn't necessarily believe it, even though the numbers showed it. And also we got a lot of criticism from our public about, the validity of those numbers. We repeated the hooking mortality study in, I think it was 2016, maybe 2017. And basically that study had very, very similar results to the earlier study, if you ignored the length of the fish that were found to have an impact on hooking mortality in the earlier study. So if you took that component out of it, the percentage of fish that were dying across these different water temperatures actually ended up being very, very similar, between those two studies. So, it has been repeated. So, there's, obviously with anything that there's going to be some interpretation, how long did we hold the fish, things like that. We tried to account for that. We kept track of it. How do anglers, you know, actually release the fish, you know, relative to the way that we were handling them. What I can say is that, you know, these types of studies are extremely difficult to do. They take a lot of effort. They're not cheap, you know, and it's really kind of the best estimate that we've got of hooking mortality. And they're not terribly different than what's been reported in the literature as well.
Okay. So about the only tool in the bag right now for reducing hook and mortality is limiting fishing pressure during those warmer months.
Right. Yep. That's exactly right. And that's really the way that we're approaching this. You know, the three goals that we have for our walleye fishery, you know, as written in the management plan, is the number one goal is to continue to provide opportunity for anglers to fish. The number two goal is to avoid unplanned shutdowns, you know, because that's a real irritation to people. And then the third goal is to allow for some harvest when, you know, when the fish population and in this case, water temperature, I guess, allows us to have minimal impacts on the fish population.
Okay, well, I still, and I hear what you're saying, and as far as being expensive, but a lot of money gets spent on this lake.
Oh yeah, yeah,
and
yeah,
by
that
everybody, you know, and I surely think that being that the public opinion is that still, I understand those two studies are similar results, that I would think that it might be well to have another one, and the worst, it would confirm it. But I think that it might be something that would be appreciated and help settle some of this if there was another one conducted, and perhaps not only inviting DNR personnel, but also, you know, a few of these people, including the resorts, that to let them partake or be a part of this. I think another one would help with public opinion, Tom, of what's going on.
Yeah, I think let's see, I think Mark Outney's on here. Yep, I see Mark on here. I believe Mark actually took part in that study. You know, it wasn't just DNR personnel. But yeah, if you want to shed some light on that, Mark. Are you there, Mark? I see unmuted, but I don't hear anything. Okay, maybe Mark's having some issues. In any case, you know, we did have like non-DNR people participating in this as well.
But I think just having another one to refresh, because there's a different batch of people fishing this lake now than what was in 2007, and even in 2016, we start to see the angling pressure. It helped to support what you're doing right now, in public opinion. I think could maybe change or be enlightened, you know, of what hey, this is really accurate. What we're doing is right, and and help people understand. Look, the only way we got of reducing hook and mortality is take off some of the hooking, the pressure, because this is a real issue.
Right.
And it may be expensive, but like I say, there's a lot of money gets stuck in the into managing this lake right now.
Yeah.
And that's just my thoughts behind this.
Okay. Well, thank you. There we go. Okay.
Looks like
yellow
Melissa has her hand up too.
Oh,
Sorry,
okay.
Tom.
Yep, no problem. Go ahead, Melissa.
Just to kind of expand on, I'm sorry, I couldn't see who was talking with you, Tom, there, so my apologies to that man. That you pointed out that the types of anglers and the people that are now fishing this lake have changed a lot since 2006. And to me, that statement in itself helps me support what they're doing on limiting us during these high pressure times on the mortality rates, because there's a lot of people out there that, for one, like Tom said, they're not releasing the fish and they're not holding the fish like they are. They don't know how, they don't have the skill level. How many people are just out there and, out in the sun, half, in the bag, so to speak, and not watching their lines, and that fish swallowed that line. There's a lot of that goes on during that times when it is our busy season, especially around 4th of July. And we also have, better technology too that helps us locate the fish better, those that do fish more regular. So we're able to hone in on the fish faster and better too. So I think, yeah, there's a couple ingredients that support, you know, um, the no fish, the limiting of that during certain times. That's all.
Okay, thank you. Okay. Okay, I guess I never talked about the perch here. So anyways, this is what's going on with our perch population. So the vast majority of our perch fishery always took place in the winter. And I'm showing you, our harvest estimates going all the way back to 1983. But realistically, I'm having a hard time kind of understanding exactly what these harvest estimates meant relative to what our fall gillnet survey showed. And that's because we had some very, very high harvests, say prior to like 1992. We had some really high harvests at a time that our fall gillnet survey showed that the perch population was really low. It was essentially at the same level that it is right now. After 1992, it seemed like our perch and our fall gillnet survey kind of varied together. So in other words, when we had a lot of perch out there, we also seemed to have a pretty robust perch population based on our fall gillnet survey. So I don't put a lot of credibility in some of those earlier numbers. I tend to believe more what's going on after 1992. But kind of the take-home message here is that we've got a very low perch population right now, as shown in our fall gillnet survey, and our perch harvest, which, I kind of believe these numbers here. This was like kind of in that era that I think, we can believe the numbers was about 200 to 300,000 pounds of perch being harvested annual. Right now we're harvesting maybe about 5,000 pounds of perch in the winter. So that population has really taken a huge dive. And there's probably a number of reasons for that, but one of the really big ones is that, we can't ignore the impact of zebra mussels on these things. The perch population has always been somewhat variable, but what we can see is that once zebra mussels came into the system right in here in 2006, we just never managed to rebound our perch population the way it used to be, and just kind of continued to go down. Another one of the things that could be impacting our perch population is simply the way we're managing our walleye right now. We're trying to manage our walleye to maintain kind of a robust walleye population, and that could very well be impacting our perch as well. You've got a lot of predators out there, and perch are one of the primary forage species, and so they might be taking it into shorts a little bit here. So one of the really cool things that we've learned through our Creel surveys is that angling success is actually very well related to condition factor. For those of you that were here last week, recall that condition factor is simply a measure of how plump the fish are, so how fat they are. If you take a look at the fish over here in the lower left, that's a relatively normal looking walleye, as opposed to the one over here in the upper right. That's a really skinny walleye. So what we found is that, so this is condition factor on this graph across the bottom. And this is angling catch rates on this graph in the summer fishery, on this one in the winter. And what we found is that when fish are really skinny, so an average size walleye and the way we measure condition in this would be a 0. Over here, this -8 indicates that the fish are about 8% less fat than they are on average. And over here, 4, this means that these fish are about 4% more fat than on average. So in other words, they weigh 4% more than a fish of a comparable size of the long-term average on Mille Lacs Lake. And so what we see is that during periods when the fish are really skinny, we see our highest catch rates, and we see our tend to see our lower catch rates when the fish are fat. We see something really similar in the winter. It's not as well defined in the winter, and I think the reason for that is because there's so many more variables in the winter. Weather being huge. You know, we certainly get inclement weather during the summer as well, but it tends to be like a storm that might roil up the water for a couple of days, and fishing is poor because of muddy water. Whereas in the winter, what we can have is late ice. We can have a lot of snow on the ice. When we get a lot of snow, we'll typically get slush, and then the people that build the ice roads, they're not as able to get to the spots where they would like to fish. Or anglers just aren't willing to come up, and fish in slushy conditions. All those things tend to be much more long-lasting weather impacts in the winter than they are in the summer. And so I think the relationship isn't quite as good. But the bottom line is that skinny fish tend to be much more catchable than fat fish are. And so what this really, you have to think about this in the years that we've got really skinny fish, we've got some extraordinary catch rates. And the most recent year, or the most recent example of that was 2019. We didn't have a particularly robust walleye population in 2019, but we had some of the higher catch rates that we've ever seen. And those extended clear through the summer. And so one of the criticisms that we get is, how can we be saying that the walleye population is so low when anglers are catching fish basically one right after the other, and there's actually a much better relationship between angling catch rates and how fat our fish are than there is between angling catch rates and walleye abundance. Any questions on that one? Hope it made sense. Okay. So hope you guys are all mathematically inclined, because we're going to dive into this a little bit here. So how does the Creel Survey work? So first of all, we have Creel clerks that collect the data. During the summer, we have three Creel clerks on the lake. And our goal is to have every single shift covered by one Creel clerk throughout the entire summer. So we have a morning and we have an afternoon shift. Our clerks work 5 days a week. So we need 3 Creel clerks to cover all of those shifts. Our winter fishery, in the winter, we have fewer access sites that we have to cover, so we can get by with only 2 clerks in the winter. So the Creel clerks have a number of tasks, and I've listed the tasks here in their order of importance for what they have to do. Their first task is to count returning fishing boats. And again, as I explained in an earlier slide, they're only supposed to count returning fishing boats. And we've given them a number of clues as to how to determine what's a fishing boat relative to somebody who's just out there recreating. So that's the most important thing that they do, is count returning fishing boats, because all of the other estimates that we make are based on the number of returning fishing boats. So next they interview anglers. So they ask the anglers, how many fish did they catch on their trip? Oh, excuse me. And that includes the number of fish that were harvested, as well as the number of fish that released. What we use that information for is to estimate the number of fish that were harvested overall and the number of fish that were released overall. We ask them what time did they start fishing and how many anglers were on the boat or in the car in the winter fishery. And what we use that for is that's our estimate of angling pressure on the lake. And then finally, they collect fish lengths. And so any harvested fish that the anglers are bringing back, we get a length on those fish. And then anglers also, and then because obviously we can't measure the released fish, and we rely on the anglers to report the lengths of released fish that they had released throughout their angling trip. Back up a little bit. So the way we estimate weight on our fish, can't remember if I covered this or not, but it's based on a length-weight relationship that we developed from the previous fall gillnet survey. So based on that survey, we compare the, for each individual fish, we've got a length, and based on that, we basically just run a regression line, which is just establishing a relationship between how long is a fish and how much does that fish weigh. So based on that, we know on the long-term average, you know, a 14-inch fish, a 14-inch walleye weighs about a pound, 25-inch walleye weighs about 5 pounds, and then, you know, it kind of, you know, the whole range of lengths in between that. So that's how we estimate the pounds of fish that are caught. And our quotas are based on the pounds of fish that are caught, not on the numbers of fish. Oh, what I'm going to do now is I'm going to describe exactly how the Creel survey works, how we come up with all of these estimates. And you're going to have to bear with me because I'm going to start with a very, very simple case, just so that you understand the background of this whole Creel survey thing. And then I'm going to build up to exactly how we do it on Mille Lake. So on this hypothetical lake, we've only got one access site, and that's that black dot that looks like it's up around Garrison there. And on this lake, our clerk works 8-hour days, and he works 5 days a week. But we've only got one access site. And it's interesting because anglers on this lake tend to be relatively lazy, and they're only fishing for 8 hours of a day. So all of our clerk works from 8 o'clock in the morning until 4 o'clock in the afternoon. And so that covers the entire length of the angling day. Anglers don't fish anytime but from 8 o'clock in the morning until 4 o'clock in the afternoon. So what's good about this particular situation is because we've only got one access site, we've got a clerk station there. He's able to count every single boat coming off of the lake during his shifts. And what he does, or the way we run our Creel survey, is we run, everything is done in 1-hour blocks. So what we do is we count all the boats coming off the lake in a 1-hour block. And then each one of those 1-hour blocks is expanded to a full day estimate of how many boats are coming off the lake, because we know that some hours are a lot busier than others. So because our lake anglers are only fishing from 8 o'clock in the morning until 4 o'clock in the afternoon, we know that from 8 o'clock till 9 o'clock in the morning, we're going to see relatively few anglers coming off the lake. But on the other hand, from right around noon, say 12 o'clock to 1 o'clock in the afternoon, we're probably seeing a lot of anglers coming off the lake. And then at the end of our fishing day, it's probably also a busy time. We're seeing a lot of people coming off the lake at the end of our day. So anyways, what we do is we expand each and every count, each and every one of our 1-hour counts. We expand that to an estimate of all of the boats that are coming off the lake for a full day. We do that by multiplying every count by 8 hours. And then we average all of those counts together. And if we want to get an estimate of the number of boats coming off our 7-day week, because you have to remember, we're only sampling 5 days out of our 7-day week. We average all of those counts together. We average all of those 1-day estimates together, all of those 1-hour, 1-day estimates together, and we multiply them by 7 days. And that's how many boats are coming off of our lake here in a 7-day period, even though we only sampled for 5 out of those 7 days. Does anybody have any questions about that? Awesome. I knew you guys were above average. Okay, so now we're going to get a little bit more complicated. We know that our 8-hour-long fishing day is not realistic. So now we've still only got one clerk. We've got, but now we recognize that there's anglers out there fishing for 16 hours. Our clerk can still only work for an 8-hour shift because those are the rules, right? And so what we do is half of the shifts that our clerk works are the morning shift and the other half are the afternoon shift. So we try to cover the whole day, even though our clerk is only working 8-hour shifts. We're still only working 5 out of 7 days because, again, those are the rules. So our clerk is counting all the boats coming off during a 1-hour period. We expand that count to a full day, but now instead of multiplying by the length of our 8-hour fishing day, we're multiplying it by the length of a 16-hour fishing day. And so what we're trying to do now is we're trying to account for, even though the clerk is only working a morning shift, we also have an estimate for how many boats are coming off during the entire day. And what we do then is we take all of those estimates, those full day estimates, half of them were done in the morning, half of them were done in the afternoon, and we multiply, we get an average of those. We multiply that average by 7 days. And so now we have an estimate for how many boats are coming off the lake for a full week, even though we were only able to sample half of the time that anglers are actually coming off the lake. You guys understand how that works? Hope I haven't blown anybody out of the water here yet, because it's going to get harder. Okay, so now we're coming up more to what Mille Lacs Lake actually looks like. We know that we've got more than one access site here. So we've got one Creel clerk. It's working for an 8-hour shift, but now we've got 2 access sites. From past experience, we know that about half of the boats are returning to that access site on the northwest corner of the lake, and the other half of our boats are returning to the access site on the southeast corner of the lake. So in other words, the sites get an equal amount of pressure. Anglers are still fishing for 16 hours a day. So now what we have to do is our clerk is counting still 1 hour. He's counting either a morning shift or an afternoon shift. And he's only able to count one at one of our 2 access sites throughout the day. So now what we have to do is we have to account for the other access site. And so now what we do is we take our count and we're dividing it by the site probability. So the site probability is 0.5 because, so 50%. So because 1/2 of our boats are coming off to the northwest access site and the other half of our boats are coming off to that access site in the southeast. So we have to account for all those boats that are coming off on the other access site. So each site gets divided by 0.5. The counts get divided by 0.5. That count or that number then gets multiplied by 16 hours in a day. So by doing that, we're accounting for all the boats coming off all day long, morning and afternoon, for a full day, for every single count, every single 1-hour count that our clerk does. And then you average all those counts together, all those estimates together, and you multiply them by 7. And you get an estimate for how many boats are coming off of the lake during an entire week. Okay, so this then now is exactly how the Mille Lacs Creel Survey works. We know from past experience that not all of our access sites get exactly the same amount of pressure. So in this case, one of our access sites gets 75% of the pressure. The other access site only gets 25% of the pressure. What we have to do is the access site that gets 75% of the pressure, our clerk has to spend 75% of his time there and only 25% of his time at the other access site. I'm going to show an example of why we do this later, but mathematically, the reason that we do it this way is because we get a much more precise estimate for how many boats are actually coming off the lake during a certain time period. So now our sites are not getting equal pressure, but they are getting unequal pressure. So our clerk is out there sampling for half of the 16-hour sampling day, half of the time that he's sampling in the morning, and the other half of the time he's sampling in the afternoon. Okay. For every count that he does at site 1, which is the access site that gets 75% of the pressure, we divide that count by 0.75, which is the site probability. Then we multiply that by 16 hours per day, and that gives us the total number of boats that are returning on the entire lake in those 2 access sites. So we've got a whole bunch of these 1-hour counts. We've got a whole bunch of these 1-hour estimates, and we average them all together. And by multiplying that average number by 7, we come up with the total number of boats that were coming off the lake in a 7-day period. Is that clear to everybody? You guys just stunned. Okay, Mark. I can't hear you, Mark. Okay. Still having issues.
Mark, maybe you could try to call in for audio and see if that one works. Looks like Larry has his hand up while Mark's working on his audio.
Okay, go ahead, Larry.
Well, you said you got 33 sites
Yep.
on the lake. How do you determine the percentage to use addressed to each site with 33 different sites?
Fair question.
I guess.
Nope,
That's
so initially what you can do is you can actually there's two ways to actually start a Creel survey. Now understand we've been doing this Creel survey since about 1983. But the first year that you do the Creel survey, you have to make some assumptions. One assumption you can make is that all of the sites have exactly the same probability. And so they would all be sampled with the same frequency. The other thing that you can do is you can make some estimates. You can estimate that, say, Garrison has a greater likelihood of encountering a boat, so it's got a higher number of boats coming back to it in a 1-hour period than something like Isle would in here. And then as you conduct that Creel survey over a period of years, then what you can do from then on is you can actually refine the probabilities of encountering a boat at each one of those access sites. So what we do, the way that we define those is basically you look at the long-term average of what proportion of your boats are coming back to each one of your access sites. So in other words, we know that some of our boats, some of our access sites have about 5% of the boats coming off on the entire lake. And some of our access sites might have 10% of the boats coming off on the entire lake, just over a long-term average. And we do actually update those probabilities every year or two.
Tom, when you were talking 16-hour days, does that have anything to do why there is a restriction basically from quite a bit of the year for open water fishing that we're only allowed to fish 16 hours a day? There's a third of the day, that 10 to 6, that we can't fish.
There's a little bit of a history there, and most of which occurred before I got here. So I'm kind of speaking from what people have told me. There was an initial night closure that was enacted, I believe it was back in the 1990s. And that was based on some citizen input. They figured that there were too many, I think at that time it was too many big fish. Was the feeling that too many big fish were being caught in the middle of the night. And so the night fishery was restricted. I can't remember what time frame that particular night closure covered. I think it was relatively early in the year. And then once we started getting more restrictive with our fishery, we enacted a night closure later on in the year just to reduce harvest. So so initially our Creel surveys did actually go till midnight, but now they stop at 10 o'clock simply because that's when people can't fish anymore.
Thank you.
Yep. Okay. Hope I haven't overly confused anybody with this stuff. So I'm going to work through an example now of how this thing works. And what I'm going to do is I'm just going to focus on what is our average how we calculate our full day estimates, because after that, you're just basically multiplying by the number of days in your sampling period. You know, in the previous estimates, I always used a week, so I was using 7 days. In reality, on Mille Lacs, it's however many days you can fish in May, and then after that, it's however many days are in your 2-week period, either 15 or 16. So I'm going to use my 2 sites like I used in my example. One of my sites has a probability of 0.75. So in other words, 75% of the boats are coming into site 1. And based on that, you can see that 75% of my sampling effort has to be directed at site 1. Site 2, on the other hand, has a boat encounter probability of 25%. So it's only 1/3 of what happens at site 1. And so this kind of gets back to the question that Larry was asking. On average, site 1, I see 8.5 boats per hour, and site 2 is 3 boats per hour, and that works out pretty close to 75-25% split. So if I have a count of 7 boats returning at site 1, I divide that 7. Let's see, where's my mouse? I divide my 7 by 0.75. And so what I'm estimating is actually, there was actually 9.3 boats coming back between site 1 and site 2 for that 1 hour period. And then I expand that to a full day estimate by multiplying 9.3 by 16 hours. And so my estimate for this 1 hour period is that there was 149.3 boats coming back on the lake for the full day. I do that for every single count that I've done through that day. And you can see that, you know, each one of these estimates, they're not identical. But what happens then is I average everything, and my estimate for the whole day based on all of these individual counts is that 184 boats came. There were 184 fishing boats returning to access sites across the lake for that full day. And this other red number down here, it's a statistical term. It's called a standard error. It doesn't mean that it's wrong. It's just a measure of how precise my estimate is. So in other words, the smaller my standard error is, the more faith I have that this is actually a pretty good number up here. So, and this kind of goes back now to the question that Larry asked earlier. So now what you might be thinking is, well, what if we just really screwed up? What if our probabilities, if we made an error in our probabilities, okay, what would happen to my estimate? So I modeled that for you. And so what we're saying here now is that exactly the same as site 1. I think that 3/4 of my boats, 75% of my boats are coming into site 1, and 25% of my boats are coming into site 2. However, when I look at how many boats I'm actually counting on average at site 1, I see now that it's completely flipped from what it was in my first example. Now, even though I'm spending an awful lot of time at site 1, I see that, geez, I only counted 3 boats on average per hour at site 1 and 8.5 at site 2, which was a complete flip from the first example here. I worked the expansions. Now what you can see is that there's a much broader range of estimates here. So these estimates from site 1 are really low, and the estimates from site 2 are really high. But when I average all of these things together, it comes up with exactly the same number, exactly the same estimate of how many boats are coming back on a day as it did in this earlier example. The difference is that now my standard error is way bigger. And so what that means is that in this estimate here, I have much less confidence that this is a really, really good estimate, excuse me, because my standard error is so large. So the difference is not that, well, what this really means is that even if I completely screwed up my probabilities, my estimate remains unbiased. So in other words, screwing up my probabilities just gives me less confidence in my estimate, but it is neither high, it is biased neither high nor low. What do you guys think of that one? Okay. Hope I didn't overwhelm anybody here. So now this is only the number of returning boats that are coming back. And as I said earlier, that's the most important information that our clerk collects, because all of our expansions are based on the number of boats that are returning. So the harvested fish. If you recall what I said, that one of the things that our clerks do during the angler interview, they ask anglers, how many fish did you harvest? So all of the boats, all of the interviews that our creel clerks conduct, we get an average number of, in this case, walleye. We generate on average how many walleye were coming back per boat. And to get the number of harvested walleye that were coming back in a particular time period, we multiply the number of returning boats during a particular creel period times the average number of fish per boat. And then the weight is simply we can get an average length of those fish that were harvested because the clerk measured them. And then we convert that length to a weight based on the length-weight relationship that we developed in our fall gillnet survey. And we just multiply the average weight times the estimated number of fish, and that's how we estimate the weight of fish that was harvested. For released fish, it's exactly the same. The anglers tell us how many fish were released. We get the average number of released fish per boat. We multiply that by the total number of returning boats, and then we get the number of fish that were released. And same thing, we can convert that weight of released fish simply by looking at the average length of the released fish, multiplying and converting that to an average weight, and then multiplying that by the total number of released fish. The hooking mortality then is the number of released fish that we have times the hooking mortality percentage. And then the weight of the hooking mortality is the average weight of all is based on the average length of the released fish. Then we multiply that by converting, or we convert that average length to a weight, and then we multiply that by the number of fish that were released, and that's how we estimate the weight of the fish that died due to hooking mortality. How am I doing? Okay. Now, I'm all open for questions here.
Tom, Steve here. So a lot of this hinges on the honesty of the anglers that you actually interview.
Right.
And the further we work along those numbers, I don't know, some of it seems to me to be a stretch. I know you've been doing creel surveys for a long time, and
yeah,
important management tool, but I don't know. You just listen to some anglers, and I don't know.
Yeah, I know exactly what you're saying. And so what I would say is, it's not necessarily the honesty of the anglers, though I acknowledge that can be an issue. But just having done Creel Survey, reading people's body language, you kind of get a feeling for when they're actually consciously lying to you. My greater worry is the ability of anglers to recall how many fish they actually released. And just from my personal experience, I know when I'm out fishing, if I only caught 2 fish in a day, it's very easy for me to remember that I only caught 2 fish. I know when let's say I'm fishing bluegills or something, species that you can expect to have really high catch rates. Up until about 5 fish, I really know how many I caught, but all of a sudden my brain gets a little bit woozy, so somewhere between 5, I'm out there, I'm fishing. I know I've either counted some or I haven't. And so all of a sudden I didn't just catch 5 or 7. Now I think, okay, maybe I think I caught 10. And so when we have really, really high catch rates, I actually worry about anglers' recollection of how many fish they released. And my greatest worry is that anglers are eternal optimists, and I suspect that they're probably estimating high when they're telling us how many fish that they released.
Yeah, both number and then length
Yes.
too.
Yeah, we actually looked at length one year, and it wasn't as bad as I expected it was going to be. So it was 2019. It was a year that we had very high catch rates, and so Tom Jones, he's a treaty biologist that works out of Aiken. He's got a lot of responsibilities on Mille Lacs. He actually conducted an experiment where he basically recruited a bunch of DNR people to go out and fish, and with the instructions that they were supposed to measure every single fish that they released. And amazingly, the size distribution that our DNR anglers had was really, really similar to the size distribution of the fish that anglers reported to us as having been released. I was actually pretty surprised by that.
Okay.
Larry?
Yeah, I agree with what Steve's saying here. When before we had these size restrictions on this lake, when people would come back to the docks, you pretty much tell how they did because there wasn't a lot of throwback.
Right.
But once we started having restrictions on this lake, all at once everybody became a pro. They all caught 25 fish to 50 fish, and they're all too big. They had to throw them all back. And,
Yeah.
and I agree with what you're saying. There's a tendency to people be high. Very seldom people going to underestimate. So from what figures that you're given, what percentage you knock off figuring that what you're getting is reported is extremely high?
Unfortunately, we really can't do that. We have to take what the anglers are telling us. And and truthfully, when I get the feeling somebody's lying to me, I record that interview as well. And it's and when they're lying to me, I think and consciously lying. I'm not saying that they just don't remember, and they're just coming up with something. But I record that as well. I might put a note next to it that I think that this guy was not being truthful with me. But we record that information as well. And so to some degree, if they're lying, it's because they're saying that they didn't catch anything because they understand how this whole hooking mortality thing works.
And Tom,
So,
at each one of these lakes or access that I go to, there's a little sign there that says what the harvest is and this and some of the rules for the lake here.
yep.
Any thought possibility of having another little sign put up, just reminding people the importance of the accuracy, reporting to Creel surveys how important this information is, and just a reminder to try to be as accurate as possible, because these figures that they're coming up with does play a real role in what was harvested out of this lake, whether it be actually harvest or hooking mortality. But
Right.
just maybe a little reminder to people that, hey, be as accurate as you can be.
Yeah, I think that the way that I've trained my Krill clerks is that they are actually trying to tease that kind of information out of people to be as accurate as possible. And so when an angler might tell me they caught, first of all, it's like, well, did you catch any fish? Did you release any fish? And they'll tell you, yeah, I released 25 fish. Well, I start with, well, what was the smallest fish that you released? Because if you just ask them what was the size of the fish that you released, it's like they're all 16 inches, they're all 18 inches, whatever, and so if they'll tell me that, okay, I really, the smallest fish I released was a 10 incher. The next step is, well, how many of those 10 inchers did you release? And then I try to go up in 1 inch increments, just because that's what anglers are typically going to tell me. So I think that by having the clerks ask anglers in a very, very systematic way, what did they release? I think we're getting good information that way. And it's really the best that we can do. All of Creel surveys, basically suffer from the same problem. It's just on Mille Lacs because we're relying on anglers to tell us how many fish that were released, and we have to apply that to a quota. That it becomes really a challenge on Mille Lacs. That probably a greater challenge than it is on a lot of other lakes. Jody?
Correct me if I'm wrong, but I guess my look on it is, as far as you guys doing the surveys and your percentage is 75 at site one, your other percentage is at 25, and taking into all the math and the counting and all that stuff. I guess the way I look at it is Jimmy Bob tells you he catches 25. He either A, lied and he didn't catch that many, or B, they tell somebody who says that, they're out there all day and didn't catch a single thing, that most likely they're lying and they actually caught 10 and released 10.
Right.
Assuming with the math and everything like that, I'm actually very happy that I attended this class or this meeting because it made me understand a little bit better, because after you explained everything and each site and how the Creel report is done, nowhere in there is it private owners in the boats that are going back to cabins that are not actually going to an access,
Right.
or going to a resort that does not have a particular public access where people can launch their boats all day long.
Mhm.
I know a few of them, you can't launch your boat out of there. It has to be done by them.
Right.
So I'm assuming that with the math, it should semi get pretty close, as long as, like we said in the beginning, that the right numbers were plugged in to start this formula from the get-go.
Right. So when I was explaining this, I kind of used an access site, and people tend to think of that as a ramp. So for instance, at the Garrison public access, I think we do we count only boats coming into the Garrison public access there, simply because there's really no other spot to land right around that. By the time we get down to like Cove, there are private houses down in Cove and then also in Walk-On. And so even though our clerk is stationed at the public access, they do count anglers returning to private residences. Or in some cases, you're counting like 2 public accesses from one site, and you can't actually interview the people at the second access. And typically, we can't interview a lot of the people that are coming back to private residences. But what we do is that they get counted, and then all the way that those counts get expanded then is just based on the interviews that we get from all the other access sites along the lake. So in other words, we're not just looking at the average number of walleye coming back per boat at the access site that we're counting. We're looking at, for a whole 2-week period, we're looking at the average number of the average number of walleye coming back per boat from all the interviews that we've done over a 2-week period. So by doing that, I think that unless the people that are coming back to a private residence or some access site that we can't interview at, unless their catch rates are completely different than anybody else's, I think we're still encompassing what they're catching in a realistic manner.
With that being said, Tom, I'm sitting at I don't know, walk on, and I
Mhm.
can see other boats coming in. Is the average for pressure on the lake 2 fishermen per boat? I guess what's the general count of how many people are in per boat
Mhm.
on the boats that you actually don't question?
No, that's actually one of the questions we ask is how many people, well, the clerks are instructed to ask how many people were fishing. So in my experience, what I've seen is it's not unusual to have, maybe 3 people in a boat or 2 people in a boat, a husband and a wife. And in some cases, one of them isn't fishing, kicking back, reading a book or something like that. So that person doesn't get counted in our pressure. But the estimate for how many walleye are being harvested is actually, it doesn't matter how many people were in the boat, except of course that more people in the boat can have more fish coming back. But that doesn't really play into the equation at all. It's on average, how many walleye are coming back per boat.
Okay, then maybe I misunderstood you. I thought that if there was a surveyor at one launch site, they could also be watching another launch site and kind of counting those boats that are coming in without even speaking to them and counting them as returning boats.
Yes.
And they're not talking to them. They can't talk to them because they're half mile away.
Right.
Are they considering them probably 2 people per boat as far as the pressure on the lake is concerned? Or what do they do with those numbers of the people that they're not talking to that are half a mile away?
It's the same. It's
Okay.
we don't assume a certain number of people per boat. It's only of the people that are interviewed. It's the number of people that were in the boat that gets averaged, and the length of the fishing trip also gets averaged across all of the interviews that we do, and that gets applied to the average number of returning boats then. Okay. Any other questions? I know this is somewhat complex, but it's been my life for like 30 years, so I've got it on the top of my head. Okay. Well, I really seriously appreciate all of you guys coming this evening. This has been the best turnout that we've had for any one of our talks. And so this was the last of our Fisheries 101 sessions. So with hope, as we start getting into more of our MILFAC meetings, we should be able to, have a good understanding of what we're describing when we're talking to you guys. And so I really appreciate the effort that you guys have put into, understanding what's going on with our surveys.
Well, thanks, Tom, for taking time out of your busy day and everybody else on a Sunday to teach all of us newbies some of this information so we can catch up with the rest of the class. I certainly appreciate everything you guys have done for us.
Okay.
Yeah, always great information, Tom. Thank you.
Thank you, guys.
Thanks, Tom.
Yep. Okay. Signing off.